All right, thanks. Thanks everyone. We're probably gonna get started here. Oh, I'm not. The timer started. I'm not giving the talk. Okay. Next up, we've got talk on Lake Ontario preyfish from Brian O'Malley. So he'll give us an update. Do you have 20 minutes? 15, 20 minutes? Yep. Enjoy.
Okay, thanks everyone. I'll be talking about mainly two surveys today. Both are collaborative between 3 agencies and 3 research vessels shown here. USGS, New York DEC, and OMNRF. So the Lake Ontario preyfish fish community objectives are shown here. FCO 2.3, increasing preyfish diversity, mainly around first the pelagic preyfish species. We have alewife, cisco, rainbow smelt, emerald shiner, and 3-spine stickleback. FCO 2.4, this work also informs predator-prey balance between mainly alewife and their salmonid predators. And FCO 3.3 is around benthic fishes, mostly deepwater sculpin, slimy sculpin, and deepwater ciscos. Another aspect of the trawling program is that we use it to evaluate bloater restoration in Lake Ontario. So it forms this, the blue arrows on the adaptive management framework, so the evaluate and learn components. And so yeah, here's briefly the spring survey is one that targets pelagic preyfish using a bottom trawl. It's a 3-in-1 trawl, so it's different gear than is used in the October survey, which targets benthic fishes primarily. But for the most part, they provide depth stratified averages that'll be presented in kilograms per hectare for indices of the populations. So I'll start off first with summarizing some results from the spring preyfish survey. This is a map showing alewife biomass distribution. The crews completed 215 trawl sites, captured a total over 1 million fish. And 92% of the biomass was alewife. And you can see the bubbles here are indicated the size. The red X's are zeros, so areas where they were trawled, but no fish or no alewife were captured there. And you can see kind of this illustrates some of the patchiness and why we need to complete these lake-wide surveys with a lot of sites to really get a good handle on their population status. But in general here, the mean on the Canadian and US side was actually pretty similar. You'll see some of the graphs later where that has not been always the case for each year. Some of the other species outlined in the FCO, rainbow smelt, 3-spine stickleback, emerald shiner, and cisco. For the most part, catches were pretty typical for these species. The red dots are shown once we expanded the survey, starting in 2015 or starting in 2016. With the inclusion of the Ontario Explorer that helped us expand from sampling from US-only sites to then lake-wide sites. So that's why we still maintain the US Waters Index because that dates back to even further than shown here on the graph. But the red index is kind of a whole lake perspective. So one exception being cisco here, that's kind of shown a positive increase in the past several years. And that's mainly, it's not a true lake-wide index increase. It's mainly still concentrated in the eastern basin. That's where cisco tend to be captured during the survey. So in 2023, total alewife biomass was high. There's a record high density in the modern time series that dates back to 1997 here. The density index is on the right, 6,795. Fish per hectare, and biomass index was again relatively high as well. Adult alewife biomass shown on the left side here as age 2+ fish was still relatively high, but similar to the year prior. And yearling biomass known as age 1s on the right side was relatively high here, above average. And this is now we've had 2 almost back-to-back high year classes. The 2020 year class, because when this survey goes out in the spring, we're not sampling age 0s, but you're sampling age 1, so it's an indication of the year class prior. So there's been really big year classes in 2020 and 2022. So since we've expanded the survey to sample the whole lake instead of just the U.S. side, you can see that U.S. and Canadian distributions of alewife have differed from year to year. The blue ones here are the U.S. index, and Canadian on that year quite remarkably different. So just another indication of why we need to be sampling the whole lake. There are some exceptions though, like if you look at this past survey year, 2023, the US and Canadian indices were remarkably similar. And there's another year as well, 2021, the survey year. So coincidentally enough, these also tend to coincide with when there was a strong year class the year before. Oh, I think I covered most of that already. So this redesigned survey with sampling the whole lake is also, and taking into account some of that spatial distribution error that is when you're only sampling one side of the lake, has led to an increased accuracy in predicting cohort abundance estimates. These are some model results of alewife survival from one age class to the next, and the bottom graph is same thing but for growth. And so in the red points are the most recent observations from 2022 to 2023. And so in general, they're yielding mostly reasonable survival estimates and growth estimates. And these are used to predict future biomass. So where the team thinks the population's heading in the next couple of years. Again, so these are taken into account the survival, growth, and abundance data from the previous graphs. These are predictions that have been made throughout the time series, and where we're predicting the population to go is higher in 2024 and 2025. And another thing that kind of sticks out to me when I look at this graph is in general, these predictions have seemed to work pretty well. The observed points are red, and the predictions are in the box plots gray. So it's pretty neat to be able to start to do this and have some forecasting ability for populations. Switching gears to the October survey, this is a benthic preyfish survey, we call it. Samples pretty similar sites, a lot of the same sites, sometimes a little bit less. In total, there's 188 trawl tows. Oh, I forgot to mention, 2023 was the first year that both the spring and the fall added the deepest site that we have now, which is about 250 meters. I think it's right around here in Lake Ontario. So we now have our previous deepest site was 225 meters. So now we can truly say we sampled the deepest depths of Lake Ontario. So this survey captured a total of 85,000 fish, and the percent here is in biomass. So 43% were round goby, 22% deep water sculpin, 10% or about 13% alewife. Some of the indices from this fall trawl program, deepwater sculpin, if you followed this story, they were considered extirpated for a long time, and starting around 2010 we started to see them coming back in noticeable amounts, and ever since then it's been this pretty big resurgence in their population. I thought recently it was starting to level out around 3 kilograms per hectare, and then the past 2 survey years we've been a little bit more around 4 kilograms per hectare. Over on the right side is, the last 10 years, just kind of zoomed in on that so you can see it a little bit more clear. This box down here, just to kind of put that in perspective across the lakes, it's a little bit different since there's some differences in how the lakes are sampled across the Great Lakes, but definitely higher numbers in Lake Ontario compared to the other lakes. Kind of the opposite story for slimy sculpin. Again, I've talked about this a couple of years now, but slimy sculpin seem to be going in the opposite direction. Pretty remarkable declines in their abundance in the survey. The October survey, when it was originally started, was called the slimy sculpin survey because it was sampling during this era when lake trout were still low, and we saw this. We've seen this decline in them throughout time. In fact, in the most recent data point here in 2023 was a new record low. I think it was 0.00, maybe another 0.7 kilograms per hectare. So definitely the lowest, and it was only marked by by 12 individuals caught in U.S. waters. But comparatively, if you look at the Canadian waters, which is what drives, when you look at the lake-wide trend here, because that takes into account U.S. and Canada, 266 fish were caught on that side of the border. So overall, just looking at changes in percent composition for the benthic preyfish community, we kind of see sort of 3 different states now emerging throughout the time series, where during the early part of the series, it was dominated by slimy sculpin and also trout perch biomass. Then with the arrival of round goby and declines in slimy sculpin, we entered this kind of round goby dominated era from about 2005 to 2010. And now with the resurgence of deepwater sculpin, we're increasing the percent native fish in the benthic preyfish community. So that's one of the indicators is, the increase in native species and also the preyfish diversity. So that's kind of a new state that we're entering, where we still have a lot of round goby, but now we have a lot of deepwater sculpin biomass as well. Hopefully these are okay to see from the back, but these are just some sort of maps from the benthic survey as well. So I talked about how slimy sculpin are basically extremely rare in the U.S. sites. When we look at the Canadian sites, we tend to get them east of Toronto and all the way to about Cobourg. We did pick up a couple, I think like one here and maybe 1 or 2 at these areas offshore of Youngstown and Olcott. Deepwater sculpin, every transect that we have deepwater habitat greater than about 50 or 60 meters, so they're widespread. There we go. And round goby in this survey tend to be concentrated up in the eastern basin, where we have shallow water sites there, and then along the south shore, where we also have shallow trawl sites. Not present in the north shore sites, not to say that they're not there, it's just that we don't have trawl sites that are that shallow because of rocks. Bloater, 3 bloater were caught in the April survey during trawling, and there's their lengths up there. These were sent to Dr. Amanda Akis' lab in Ann Arbor. She's with the USGS Great Lakes Science Center. Couldn't really be confident in these IDs without that. I'll show why in the next slide. So that brings us up to 15 bloater captured to date from both trawling programs. I think most, or about half, have been caught in the spring, and then the remainder in the fall. Areas where they've been captured are shown in blue for this survey here this year, and Sarah Beach's talk sort of highlighted the rest of them. But for most of the catches to date have been in U.S. waters. So in October, though we've caught bloater in the past, and despite 188 trawl tows, I say we captured 0, and 0 being in quotes here, because we had 2 that were small craigenines that we decided to ship out to Amanda for ID. One came back as a Cisco, and the other one came back as which was a real surprise, as a putative hybrid between Ardidai and Hoyai. So I'll just pause for a second so you can take a look at this graph and try to figure out which one's which, or not graph, picture. Because I'll tell you, it wasn't what my expectation was. We thought that this one was going to be a bloater just because it had a big eye, and I don't know, we captured it near shore, so we thought maybe it was swimming from Oswego where it was stocked or released out of a net pen. But no, in fact, that one came back as Ardidai, and this other one actually caught offshore Point Peter, was the one that came back as a potential hybrid. So we are sending out another sample just to kind of confirm this or see if it's true, because we're all kind of surprised. But there have been larvae collected in the Apostle Islands region of Lake Superior that have been also identified as potential Ardidai Hoyai hybrids. So it is something that I think it can happen. Another piece of the trawling program is sampling and embayments. And this is a graph, or the part on the left is an image from what used to be known as the perch survey. So this was a late September, early October trawling program used to index yellow and white perch that ended in 2007. But with the shift of our benthic preyfish survey more towards October, it actually aligns really well with the dates of when that was historically sampled. And so starting in 2015, we started sampling those same sites again. And I say it was mainly the DEC in that area. But we also added Little Sodus and Sodus Bay and Bay of Quinte, at least for 1 year. So here's some, just leveraging historic data and where it ended in 2007 and now kind of being able to extend that time series with modern trawling in 2015 and forward. And so in general, the catches tend to be dominated by yellow perch biomass, one exception being Black River Bay. You get a higher proportion of white perch. Another thing we're doing with that data set, that time series, is because these are within our trawling program, these are areas where we still have high species richness and different species that we don't typically encounter anymore in the main lake, is looking at different change points when species tended to either increase or decrease. And so that's shown here with this taxonomic indicator analysis that Steph Figueri sort of pointed me to after doing this same sort of analysis with the biomonitoring zooplankton data set. I thought, that'd be pretty cool to apply it to this data set. This is Chameau Bay and Black River Bay, and these are species where we identified a positive increase in their time series, and then the top ones are ones that have decreased. And so something just to point out here, if you look at the last bubble is round goby, that started out around 2005. But you can see up here, darters and trout perch started to decline well before the arrival of round goby. So there's actually more differences among these two bays, even though they're right next to each other, than similarities in their differences in when species started to decline or increase. And that's all I got. A couple other things to highlight from the 2023 survey. So in the spring, Zach and Yvonne with the All Too Clear documentary were out with the ROV on the research vessel Cahill to do some filming, and they had some pretty cool videos of deep water sculpin. Jess Goretzky with the big bag of alewife, noting that high catch. And burbot. It's the first time since 2014 that we've seen burbot in the trawls, and I think Dr. Weidel's first burbot ever, despite his years of trawling. So that one was released, and there were actually 2 caught during the survey, I think one by DEC and one by USGS. So thanks.